When a camera flash goes off, the batteries immediately begin to recharge the flash's capacitor, which stores electric charge by the function q of t, which is equal to q subscript 0 times 1 minus e to the power of negative t divided by a. The maximum charge capacity is q subscript 0, and t is measured in seconds. We want to find the inverse of this function and explain its meaning. So what we have is we have q, which is equal to q subscript 0 times 1 minus e to the negative t divided by a. So finding the inverse of this function is solving for t. So we want to solve for t to find the inverse function, because currently right now we have q of t. We want to find t, which is the time that's needed. So what we're going to do is we're going to look at this equation and now solve for t. So in part 3, we're going to rewrite this now as q subscript 0 on the left side times 1 minus e to the power of negative t over a, and that's going to equal q. So now we're going to solve for t. So the first thing we can do is divide by q subscript 0. So we have 1 minus e to the negative t over a, and that's equal to q divided by q subscript 0. They're not the same thing. Then we're going to subtract 1 to both sides, so we get negative e to the negative t over a, which is equal to negative 1 plus q over q subscript 0. Now we want to get rid of this negative, so we're going to divide both sides by negative 1, so we get e to the negative t over a, which is equal to 1 minus q over q subscript 0. Now in order to solve for t, we can take the natural log of both sides since the base here is e. So we have the natural log of e to the negative t over a, and that's going to equal the natural log of 1 minus q over q subscript 0. So over here, we know that we can now then factor out the negative t over a, so it's negative t over a, which is equal to the natural log of 1 minus q over q subscript 0. And now we can multiply both sides by negative a to solve for t. So t is going to equal negative a times the natural log of 1 minus q over q subscript 0. So therefore, this is the inverse of that function. So we want to be able to explain its meaning. So we solve for t being the time. So that means that this gives us the time necessary to obtain a given charge q. So now in part B, it's asking us how long does it take to recharge the capacitor to 90% of capacity of A is equal to 2. So we're going to use this inverse formula here. Okay, and we're given the fact that we know that the capacity A is equal to 2. And then we also know that Q is equal to 90% of Q subscript 0. Because remember that Q subscript 0 up here, okay, is the maximum charge capacity. So if it's 90% of Q subscript 0, then that means you have 0.9 times Q subscript 0. So now we can plug in both of these into our formula to solve for t. So t is going to equal negative a, which is negative 2, times the natural log of 1 minus, we have 0.9 q subscript 0 divided by q subscript 0. So what that does is that eliminates the q subscript 0. So now we have t, which is equal to -2 times the natural log of 1 minus 0.9. So t is going to equal -2 times the natural log of 0.1. So if we put that into our calculator, we have -2 times the natural log of 0.1. So if we look at that to 1 decimal, it's 4.6. So that means it is approximately 4.6 seconds.